it's Jo Karen Hudson. This video will be on the exponent rules. We'll first start off with the power rule. For any real numbers x and y, with a not equal to 0 and b not equal to 0, our first power rule will have b to the x raised to the y is b to the x times y. If we have ab raised to the x, we'll have to raise the a to the x and the b to the x. If we have a product raised to a power, we have to raise the whole thing to the power. So we'll start off, simplify each expression using the power rule. Example 1, x squared raised to the third power. We'll have to multiply the exponent, so we'll have x to the 2 times 3, which would be x to the 6. Here we have 5, and we have to raise both the x to the 7th to the 4th and the y understood to the 1st to the 4th, so that we will have 5x to the 7 times 4 is 28, and we will have y raised to the 1 times 4, which is 4. X to the 28th and y to the 4th. 5x to the 28th and y to the 4th. On example 3, we're going to raise both of those. We're going to raise the negative 6 to the second power and the x to the 9th to the second power. So you can use your calculator for negative 6 to the second power. Let's see. Parenthesis, negative 6 raised to the second power. That would give us 36. And our x to the 9th raised to the second power, that's when we multiply the exponents, would be x to the 18th. Example 4. On this example, we'll need to make sure that we raise the negative 2 to the 5th power. This is a product raised to a power. The x to the 8th to the 5th power. The y to the 10th, raising that to the 5th power, and the z to the 3rd, raising that one to the 5th power. We can use our calculator for negative 2 raised to the 5th, so we'll have parentheses, negative 2 raised to the 5th, which would be negative 32. When you raise a negative number to an odd power, it always turns out to be negative. Then we'll have x to the 8 times 5, which would be x to the 40th. We'll have y to the 10 times 5, which would give us y to the 50th. And we'll have z to the 3 times 5, which would give us y to the 15th. Final answer on that one. Okay, let's get the fraction rule. For any real number x with b not equal to 0, a over b, the fraction a over b raised to the x would be a to the x over b to the x. We raise the numerator and the denominator both to the x power. Simplify each of the following expressions using the fraction rule. Example 1. 1/9 squared. We'll square the numerator. We'll square the denominator. 1 squared is 1. 9 squared is 81. Example 2. X over y raised to the 8th. We'll raise the numerator x to the 8th. We'll raise the denominator y to the 8th. And we've done it. Now, the negative exponent rule. For any real number x with b not equal to 0, b to the negative x is equal to 1 over b to the x. Notice if we have a negative exponent in the numerator, it goes down to the denominator and becomes positive. It makes the reciprocal. If we have a negative exponent in the denominator, if we'll let it rise to the top, bring it to the numerator, it will become positive. Rewrite the following expressions with positive exponents on the variables. Now there are no variables here, so but we want to remember to write positive exponents on the variables. We've got several examples. Example 1, 2 to the negative 3 is 1 over 2 raised to the positive 3. Now, we want to simplify this because we can. 2 raised to the third will simplify. 2 raised to the third. becomes 8. So we have 1 over 8. Example 2, negative 2 raised to the negative 3. So this is going to turn out negative. This negative exponent is going to bring 2 to the denominator, so we're going to have 1 over 2 to the third, which would be negative 1 over, and 2 to the third we just found out in the previous problem was 8. Okay, negative 2 raised to the negative third. The negative exponent drops this down to the denominator. We'll have 1 over negative 2 raised to the positive 3. 1 over negative 2 raised to the positive. Negative 2 raised to the positive 3 is negative 8. 1 over negative 8. Or we might write our answer negative 1/8 or negative 1 over 8. Either way. Normally we don't leave a negative in the denominator. Example 4. X to the negative 3. You see we have an x raised to a negative power in the denominator, so if we will just let it rise to the numerator, it will become x to the third. We've left the variable with a positive exponent. Fraction raised to a power. Now, I like to raise each part of the fraction to the power and then take care of the negative exponents. Some people do it just the opposite, take care of the negative exponent first and then raise it to the power. But I will be doing it this way. I'm going to raise the fraction, both the numerator and the denominator, to the negative 6 power. 5 to the negative 6 over y to the negative 6. Because this is a negative exponent in the numerator, I will take it to the denominator. Because this is a negative exponent in the denominator, I will take it to the numerator. So now I have y to the 6th. And with my calculator, I will put in 5 raised to the 6th. And that gives me 15,625. 15,625 would be the final answer on that one. We like to simplify. If we've got a number raised to a power, we always like to simplify that. Example 6. 2, we're going to write down the 2. Now we have a negative exponent in the numerator. If we'll take it to the denominator, it will become positive. And we want to leave our answers with positive exponents. B to the negative 6 in the denominator becomes b to the positive 6 in the numerator. And we have a final answer here because our variables have positive exponents on them. Now here we want to raise our 7 to the negative 3. We want to raise our x to the 4th to the negative 3. And we want to raise our y to the negative 9 to the negative 3. So we'll have 7 to the negative 3, which would be 1 over 7 to the positive 3. This would give us x to the negative 12. X to the negative 12. Well, I should have made up my mind how I wanted to do that. Okay, let's get everything raised first before we start flip-flopping anything. 7 raised to the negative 3, x raised to the negative 12, and y to the positive negative 9 times 3 is positive 27. So now you see we have 2 of them that have negative exponents. This one has a positive exponent, so it will stay in the numerator. This comes, the 7 to the negative 3 comes to the denominator and becomes 7 to the positive 3. The x to the negative 12 comes to the denominator and becomes x to the positive 12. And we'll want to figure out what 7 raised to the third power is because we can. 7 raised to the third, we can put that in our calculator, is 343. So we'll have y to the 27th over 343 x to the 12th. All right, let's get the quotient rule. For any real numbers x and y with b not equal to 0, b to the x over b to the y, or dividing, is equal to b to the x minus y. When we divide, we subtract the exponents. So we have x to the 5th divided by x squared, which would give us x to the 5 minus 2, which would give us x to the 3rd. Let me just show you how that works. X to the 5th means you have 5 x's in the numerator. X to the 2nd means you have 2 x's in the denominator. If you cancel out what they have in common, you see you will have 3 left in the numerator. But it will be easier to subtract the exponents than to draw a picture every time. Now we're going to subtract the exponents here, so we will have x to the 23 minus 45, or we'll have x to the negative 22, which would be 1 over x to the 22nd power. We want to leave our answers with positive exponents. You see, this one is bottom heavy. The answer is going to turn out to be in the bottom, in the denominator. 45 is bigger than 23, so when you subtract 45 minus 23, you will have 22 left in the denominator. It's bottom heavy, so the x's belong in the denominator. Example 3. Negative 10 divided by 2, negative 10y to the 7th divided by 2y to the 3rd. So we'll start off with negative 10 divided by 2 is negative 5, and y to the 7th divided by y to the 3rd is y to the 4th, because we subtract the exponents. 7 minus 3 is 4. It's top heavy, so the y's belong in the numerator. Negative 5y to the 4th. Example 4. We can reduce the 15 over 9. Let's see. 3 goes into 15 5 times, and 3 goes into 9 3 times. So we get 5 over 3. The m to the 10th stays in the denominator, but the m to the negative 3 comes to the denominator and becomes m to the positive 3. That's the way I like to handle it. So that we'll have 5 over 3m to the, these are like bases. I'll add the exponents, m to the 13th. This is our last example on this section. We'll have 26 divided by 13 will give us 2. And we have m to the 8th and n to the 7th. And the m to the negative 4 can rise to the top and become m to the positive 4. And the n to the 1 can stay in the denominator. So that now we have 2. And let's combine the m to the 8th times the m to the 4th. And that would give us m to the 12th. So now we use those up, and n to the 7th divided by n to the 1 would be n to the 6th. Final answer on that one. This is Jo Karen Hudson. Thank you, and have a wonderful day.